Okay, now coming to the topic, that is Article 26.3, and it's about combination of capacitors in a circuit. किसी भी सर्किट में हमें according to our requirement we may require 1, 2, 3 or more than this number, the number of capacitors in a circuit. So for that we may arrange the capacitors in series or maybe in parallel, whatever the requirement is. So उसके लिए जो combination of capacitors है in a circuit, we have two different types of combination. Number one is parallel and number two is series. ये बिल्कुल वैसे ही है जैसे हम रेजिस्टर्स को जो है सर्किट में लगाते हैं, और रेजिस्टर्स भी हम अरेंज करते हैं आइदर इन सीरीज और इन पैरेलल. मेन टारगेट हमारा क्या होगा? दैट इज टू फाइंड द इक्विवेलेंट कैपेसिटर in a circuit. So suppose we have more than two capacitors in a circuit and we want to find the equivalent capacitance of that circuit, the capacitors present in that circuit. So for that we will solve the parallel combination as well as the series combination. इक्विवेलेंट कैपेसिटेंस क्यों फाइंड करना ज़रूरी है? इट इज़ बिकॉज मे बी हम अपने सर्किट को मिनिचराइज करना चाह रहे हैं और हम चाह रहे हैं कि हम मिनिमम जो है उसमें कैपेसिटर्स जो हैं उनको यूज़ करें. सो फॉर दैट हम तमाम सर्किट, ओवरऑल सर्किट जो है उसकी कैपेसिटेंस कितनी आ रही है वो फाइंड करके we may use the value for that capacitance in the circuit, the single value of that capacitance in a circuit, or maybe there is a possibility that we are unable to find the value of the specific value for different capacitors that we want to use in a circuit. So for that we may solve the equation and find the equivalent capacitance which may be available for us to use in the circuit. So these are the two reasons for which we may need to find the equivalent capacitance of a circuit. Now I will solve one by one. First I'll solve the parallel combination and then I'll solve the series combination. So for parallel combination, let us draw the diagram. Suppose I have these two capacitors connected in parallel. This is source, this is C1, this is C2. Now we know that if we connect a conducting plate with the positive terminal of the battery, naturally all the electrons, they will be attracted towards the positive terminal of the battery, leaving the plate positively charged. Now on the right side I have the negative terminal of the battery and this conducting plate is connected to the negative side of the battery. So naturally all the positive charges, they will be attracted towards the negative terminal of the battery, leaving the negative charges on the conducting plate. As there is this air gap or some dielectric present within these two conducting plates, so they won't be able to cross over, and the electric field will be from positive to negative side. Now suppose these capacitance have some capacitance in microfarad value. Now I want to find the equivalent capacitance for these two capacitors present in this circuit. So for that, I have to follow certain steps. Step 1, as I have explained already, the left side, it shows that the plate, it has all the positive charges. Second, on the right side, plate has all the negative charges. Because it is connected with the negative terminal of the battery. The third point is that the individual potential difference across capacitors connected in parallel are the same and are equal to the potential difference that is supplied by the battery. That is V1, V2, VB, that is potential of the battery, is equal to the potential across capacitor 1, which is equal to potential across capacitor 2. So overall potential will remain the same when we have capacitors connected in parallel within a circuit. So there will be no drop of potential, but Q will vary. Each capacitor will store charge according to its capacity, and therefore Q1 will have its own value and Q2 will have its own value, and we know that Q is equal to CV and CV. We have C1, V1, C2, V2. So if I need to find the total charge within the circuit, for that I will have Q is equal to Q1 plus Q2. So this is equation 1, this is 2, let this be A. Now putting 1 and 2 in equation A, I'll be getting Q is equal to C1 V1 plus C2 V2. From here, let's go up here. Sorry, मेरे पास बहुत बड़ा बोर्ड नहीं है, so इसी तरह इसको सॉल्व कर सकते हैं. Also, Q will be equal to CV, that is total capacitance, the equivalent capacitance of the circuit, and the total potential applied to the circuit. So I can replace this in A. So replacing, replacing 3 in B. So the B is, I have C equivalent VB equals to C1 V1 plus C2 V2. As discussed in point 3, discussed in point 3, VB is equal to V1 is equal to V2. Therefore, I can cancel these and I am left with C equivalent equals to C1 plus C2. So this is a generalized equation. I can write it as a generalized equation to calculate the equivalent capacitance for parallel combination. So if I have more than two capacitors in a circuit, I may write CEQ is equal to C1 plus C2 plus C3 and so on. So this is the generalized form to find the equivalent capacitance within a circuit where the capacitors are connected in parallel. If you remember, for resistance, when we have parallel combination, the equation was, it's opposite. 1 over R is equal to 1 over R1 plus 1 over R2 and so on. So whenever you have resistors in a circuit and you have arranged the resistors in parallel combination, you will have to find the equivalent resistance by taking the reciprocal of the sum of all the resistors. But in case of capacitors, you simply have to add them and you'll get the equivalent capacitance of the circuit. So this is it. Now I'll try to solve a problem for this. So alright. One thing which I want to share here is that remember one thing. Just remember one thing. Although it's very obvious, but still, that the value for the equivalent resistance will always be greater than the value of the greatest capacitor present in the circuit. So whatever the equivalent resistor capacitance is we are getting, it must have the value that should be greater than the value of the maximum number of the highest number of, that a capacitor have in a circuit. It has to be greater than that. So suppose if I am getting the equivalent resistor capacitance equal to 10 picofarad, then it must be greater than 8 picofarad, and 8 picofarad is the greatest capacitor which is present in the circuit where the capacitors are connected in parallel to one another. So it's a check that whether the answer you are getting after solving the problem is right or incorrect. So it's just a check. So example is, suppose I have capacitor 1 and capacitor 2 and capacitor 3 in a circuit C1, C2, C3. This is terminal A and B, and it has 12 volts. So I1, I2, I3. Let C1 be equal to 0.1 microfarads, C2 be equal to 0.2 microfarads, and C3 be equal to 0.3 microfarads. So प्लीज ट्राई टू सॉल्व, और मैं इधर सॉल्व करती हूँ, आप लोग अपने पास सॉल्व करो। लेट्स सी जो है वो क्या आंसर आता है। अब इसमें सबसे पहले तो मुझे ये बताओ कि व्हाट विल बी द वोल्टेज अक्रॉस V1, V2 and V3। obviously 12 volts, ठीक है। तो इसका मतलब ये है कि वोल्टेज अक्रॉस ऑल द कैपेसिटर्स इज सेम। फिर हमें ये पता है कि Q, total Q will be sum of Q1, Q2 and Q3। See, so these Q's are different. For that we have to find the equivalent capacitance, so that we may find the total Q. And to calculate this, we simply have to use the formula Q is equal to CV. Now first try to find the equivalent capacitance of the circuit. So draw the circuit again. Draw it. C1, C2, C3, point 1, point 2, point 3, and all of these are in microfarads. Okay, now first find the equivalent capacitance of these two, C2 and C3. I'll do it stepwise so that if you try to solve it with more than three capacitors, you will know how to how to solve the circuit step by step. So please हासिल करने की जरूरत नहीं है, जल्दी करोगे तो गलती करोगे। तो मेहरबानी करके इसको स्टेप वाइज सॉल्व करना। This is A, B and C1. Let this be C prime, and C prime is C2 plus C3, which is equal to 0.5 microfarads. So C prime is C2 plus C3 and I am getting 0.5 microfarads. Now we have to add this to find the equivalent capacitance. So the next step will be, this is C, I call it C equivalent, which is equal to C1 plus C prime. So which will be equal to 0.1 plus 0.5, which is equal to 0.6 microfarads. So the equivalent capacitance of this circuit, equivalent capacitance of this circuit is 0.6 microfarads. Total voltage is 12 volts. So now I can easily calculate the total charge. So the total charge will be CV, which is equal to 12 into 0.6, which is equal to, now one thing, this is not only 0.6, this is 0.6 microfarads. So I have to convert this micro into SI system, which is this. Now the answer will be 7.2 into 10 raised to the power minus 6 coulombs. So this is 7.2 microcoulombs. So this is the total charge which is present in the circuit that we are discussing. Now, if you want to find the charge on each capacitor, it is very easy. You will simply have Q1 equals to C C1 V. The value of C1, you know the value of C1, you put the value of C1 over here, you have the voltage, you will find the charge on capacitor 1. For capacitor 2, simply this formula, and for capacitor 3, you will use this formula. Just remember that whenever you are trying to solve it, make sure that the units are same. Otherwise, you will find that you won't be able to find the answer, and it will be incorrect. So this is all for the parallel combination of capacitor in a circuit. I hope it's clear.